Okay, we're going to continue on talking about more about functions and function notation. So here we're going to answer the following using the table. So we have a table of values, which by the way means we only have 1, 2, 3, 4 ordered pairs. We only have 4 points. On a graph, we wouldn't have anything that would be connected continuously. We just have 4 distinct points. So if we say f of -5, that means the x is -5. So I look at my table for -5 and I get y is equal to 2. So this is equal to 2. F of -3 means I'm going to look on the table for -3 and give me my corresponding y value, which is 10. What's f of 0? Who can tell me? 2. Does everyone see where we're getting that? And what's f of 6? 10. Now, this one is a little bit trickier. You're going to be solving. We want to find the x values that give us a y value of 2. You see how the x is missing? So what x values give us a y value of 2? -5 and 0. So since we solved, we can use set notation to list those two numbers. -5 and 0 are the x values, or you could say x equals -5 and x equals 0. Okay, we wanted to find the x values that give us y is 0, or y is 2. A lot of people get confused about that one, so that's why I wanted to point that out. Okay, here we're going to use the table now, or sorry, the graph. It says given the table, but it means graph. Okay, so we have this graph, f of x, and later on in your Math 111 class, you'll start to learn about this type of function. This is called a cubic function. It's going to be x to the third power. Well, something involving x to the third power. And we're going to use the x value 4. So if I go to x equals 4, I'm going to actually go onto the graph and find the ordered pair 4, comma, what's the y value? Yeah, -3. So this means f of 4 equals -3. We want f of -4. So now I go over to where x is -4. And what's the y value when x is -4? 0, exactly. F of -4 equals 0. And then here we have f of 0. So that's going to be our y-intercept. We go where x is 0 up to the line, and this point is 0, 5. So f of 0 is 5, which is, by the way, the y-intercept. I'm only bringing that up because later on we're going to be doing a lot with y-intercepts and graphs, so it's kind of good to know. Now here, what's the difference between f of 0 and find all the x such that f of x equals 0? What's the difference? Here we want all of the x values that would give us y equals 0. And by the way, y equals 0 is the equation of the x-axis. So we have 1, 2, 3 x-intercepts. So my x values are -4, 2, and 6. Does that make sense? Why I have 3 of them? Okay. Is this a function, by the way? Yes, it's a function. The x's, the y could repeat, but the x's can't. Okay, so now let's look at this word problem. We have a ball is thrown upward from initial velocity of 136 feet per second. Its height, h in feet, after t seconds is given by this equation in function notation. H of t, call that height as a function of time. H of t equals -16t squared plus 136t. And by the way, this is the graph right here, and we see that x squared, which we call, or t squared in this case, creates a parabola because we call this a quadratic equation since the largest exponent is 2. So the ball is in the air for 8.5 seconds, and the graph of the function is given. And you can also see this graph if you were to go to your graphing calculator and you typed in y equals, you could use y and x as opposed to h and t. So if I were to take any line on my graphing calculator and type in negative 16, and by the way, you would need to use the negative as opposed to subtract, x squared, and then what else do we have? Oh, negative 16x squared plus 136x. And by the way, your graphing calculator does have t in it, but you wouldn't want to use t because you only really want to use x. It's not going to recognize that as a variable. And then if I push graph, you're going to notice that I'm not seeing the exact same shape. Does anybody have any ideas as to why I'm not seeing the exact same graph on my screen as what's showing here and what I could do to fix that? Yeah, well, it's actually not to do with so much the table, but it's actually to do with the viewing window. Right now, the window is not set up the same way that the graph is set up because it's going up 10, down 10, over negative 10, over positive 10. So if I press window, I can actually change the viewing window and set it up just like you see here. This is my x-axis, so what's the x minimum value that I would need in order to see this graph? The smallest x value, 0. What's the, over here is going to be my x maximum, and what would be the maximum x value I would need to be able to see it? At least, yeah, and we can overshoot it, so we can go to 10, so we can go 0 to 10, and that's already set up. X scale means how is it counting? This is actually counting by half, but that's not really going to change the window at all, so you can skip that part. Now let's talk about the y minimum and y maximum. Here's my y-axis, and so my y minimum, what's the smallest y value I need to see this picture? 0. Y minimum is 0, so I can change that to 0. What's the maximum y value that you're going to need? And you can kind of see the scale. Here, the scale is counting by 25, even they're only labeling 50 because they're skip counting, right? 25, 50, 75, 100. So what do you think the maximum y value would be? 300 would get us there. Good. And so I'll go to y maximum and I'll put in 300. Now you could change the scale to 25. It's not going to really affect your graph at all, but you might change the scale. It doesn't matter. And now if I press graph, look at that. I'm able to see the whole entire picture of the parabola. Okay. So there's going to be a lot more features that the graphing calculator can do, and that could be helpful. All right. So now if we want to go back to some of these questions, we're going to label the units on the horizontal axis. And by the way, to remember horizontal, I remember H. Horizontal axis is the code word for the x-axis, or in this case, the t-axis. So what units would we include? What are we talking about? What is t representing? Yeah, time in seconds. So that's putting a label on that horizontal axis. For the vertical axis, I remember V for vertical. It's like an arrow pointing down. So here's our vertical axis. What units are these numbers representing? It's saying the ball's height in feet. So you could say height in feet. And that's labeling those axes. We just did that, and with the units. So we have feet. It's not height in meters. It's not height in miles. Did you have a question? Mm-hmm. Sure. Yeah, just so long as we know, it's not time in years, it's not time in minutes or hours, it's time in seconds. So just putting the units, and he's asking, can you put that in parentheses? That's fine too. Okay, does the graph represent a function? What would you say? Yes, it does. It passes the vertical line test. State the domain. Now, this one is a little bit tricky because the domain, you could say, of the equation goes on for infinity. But we're talking about the domain in the context of the word problem. So what would be the domain then in the context? Yes, exactly. 0, and we include that, to 8.5 because that's when the ball lands on the ground. Now, most graphing, if I were to show more of the equation on my calculator, it's true that the graph would continue on, but we're talking about the domain within the context. Okay. Maximum height occurs at 4.5 seconds. And we can see that here. Here's the 4.5 seconds. The maximum height is occurring. Find the maximum height. Any ideas about that? How could we find the maximum height? It's hard to sort of estimate it from the graph, isn't it? So what can you do to find out exactly? Yes? Yeah. And now if you couldn't exactly tell from the graph what it is, could you use something else to figure it out? What about the equation? Finding h of 4.25, plugging in negative 16 times 4.25 squared plus 136 times 4.25. Now, since I have the equation already in my calculator, I could use the table of values, but it would take a little bit of setting up. So why don't I go second quit, and I'll go negative 16 times 4.25. Oh, wait. Oh, 4.25 is what it's asking. Oh. Okay, you're right. I messed up. 4.25. Look, it's my second mistake of the day. Good job finding my mistakes. 4.25. You're right. I wasn't even exactly at the top when I had 4.5, so that didn't make any sense. Okay, now I push enter, and I get 289. So that means the maximum height is 289 feet. Okay, and so a lot of you were coming up with estimates based on what you saw on the graph, and that's okay. You can get kind of close, but it's better to use the equation since we have that. State the range. What is the range in the context of this word problem? Yeah, it goes up to the maximum height, so we needed to know that maximum in order to get part of the range. What's the bottom part of the range? Where does the ball start and land? It starts on the ground at 0, and then it lands back on the ground, but the maximum height is 289, and I'm including both of those endpoints. Okay, what's the height of the ball after 7 seconds? So again, we could go to our graph, we see 7 seconds, but it might be hard to exactly find the y value. So what's another way you could find the height at 7 seconds? Exactly. H of 7 equals negative 16 times 7 squared plus 136 times 7. And if we go ahead and plug that in, now some of your newer calculators, you could scroll up and push enter, and then you could just go in and delete. Or you could even use your table of values. Oops, now I'm deleting in the wrong direction. 7 squared. And then I'm going to change this one, delete, to 7, and enter, and we get 168. So see how if you were estimating, you might not get exactly right looking at the graph, and that's why we're using the equation. So we plotted that ordered pair. After 7 seconds, the height is 168 feet, if we want to include the units. And what would this mean? Interpret h of 3 equals 264. What would that mean in a complete sentence? And then let's plot that ordered pair. Yes, after 3 seconds, the ball is at 264 feet. And so if we go over to 3 and up to our graph, plot the point here, label it 3, 264. Okay, any questions about any of this using the graphing calculator? While I'm at it, since I have the graphing calculator handy right here and I have the graph, let me just show you one more thing, and that's how you could actually find that maximum height and check that, because we plugged it in, but if you wanted to find that maximum, there's actually a way to do that. If you go to second trace, you get a calculate menu, and you have value, 0, minimum, maximum, intersect, and then some other things that are going to be more relevant for your calculus classes. How could you find the maximum? What do you think? Well, press 4 for maximum, and then you would go left bound, means go on the left-hand side of the maximum, enter. Go right bound, go on the right-hand side of the maximum, press enter, and then press enter one more time, and it's telling you the maximum is 4.25. Okay, not 4.5. Easy mistake to make, right? And you see the maximum height there, the Y value, 289. So I'll do it one more time. Second, calculate, and under that calculate menu, which one of these is going to find the maximum? You can either scroll down or press 4. Going over to the left-hand side of that maximum, you push enter. Scroll past the maximum to the right-hand side. Anywhere on the right-hand side, doesn't matter. Press enter, and now it's going to ask you to guess. But if you press enter one more time, it will just tell you what the maximum is, and it gives you that ordered pair right at the bottom of your screen. Those are for newer calculators. The older ones might not have that feature. Okay, I did want to mention one more thing really quickly, and I'm just going to go back to one of these examples. I realized I was giving you always these domain and range in interval notation, but I just wanted to point out the fact that you could also use set builder, and we were talking about set builder notation in a previous lesson. So if you wanted to say everything from negative 8 up to infinity, you could say x such that x is greater than or equal to negative 8. So that would be another way to use the domain and the range. I just felt it was easier just to be consistent with the interval notation. But you want to, get used to both and practice them interchangeably. If you had all real numbers, you could say x such that x is a real number. And that would be set builder notation that would mean the exact same thing as that interval. Okay? So you could really, for your domain and range, you could use interval or set builder notation. Sometimes people have a preference.